everyone. So I've spent this weekend, researching bit on agentic abstract, and I realized that it's prone to bit of hallucination. So what I've done here, this is that because normal vanilla graph rag uses, graph retrieval plus, rag. Where I have done is I've built a custom graph which has explicit model relationship, so they're less prone to hallucination. And then I've used FAISS for the RAG part. So it's similar to Graph RAG, but more of an optimized version, right? And how made agentic is, for the agentic bit, I have implemented something called code agents here. So I've used tool agents too, but so small agents give you something called code agents. So the normal tool agents are tool calling and orchestration. Everyone knows that LangChain does it, and everyone does it. What code agents are is something for the issues like how many hours in strawberry. If you give this to code agent will of course work correctly here because it will write a Python code to solve a problem, and then and also call your tools which can be used to answer it. So it does all the orchestration, calls your tool too, but for your task it first writes a Python code, then runs the Python code. So, this is why code agents are so good. And that's why they use Anthropic. Okay, everyone are using those code agents now these days. I mean, it's not real productionizable. It's still, a good system, but again, it's still ongoing research for it. Okay, sure. Let's build system here. So meanwhile, I'll run this and I'll wait for it to run, and meanwhile I explain everything here. So for example, we are using, as I told you, we are using code agents here, the tool agents and the code agents of the small agents. This is the whole prompt. These are all the tools, the model, the temperature, and everything. Okay. And as I told you, the main components are the network and the RAG. So let me show you what we are doing with networks. For networks, we are using three CSV files, and it's a Kaggle file with 50K movie data before 2007. And this is why I'm using, so if I'm for the tool agent, I'm using Kendeck because before 2007, I've asked the prompt or the agent to use in the system prompt to use these two to get more information. But before 2007, they will use the model agent will use the data which is in our database, in our graph. So, there are three CSV files. One is the keyword file, which will tell you movies, keywords, and the second is the movie metadata, for example, whether it's rated or what's the budget, genre, title, overview. Overview is the movie description. This is what we're using for the RAG embedding creation. And finally, the CSV files, which is finally the credit file, which has the cast, crew, and all the information. And we're using all that to create the graph. So for the graph, we are using the multi digraph. So what multi digraph is? Multi relationship directional graph, right? And this is what we are using. But I've intelligently made it bidirectional too. So we are not using direct bidirectionality, but in a very smarter way. So how we are maintaining bidirectionality is, we have the primary node, the movie node, and then we add many nodes. For example, we have the release date node, but we have different relationships being maintained. One is the movie, from movie to date is movie released on, whereas other ways year release movies. So for example, for 1999 you have Inception, but there will be multiple movies in 1999 having the multiple relationships, and this is how it works. So all the relationships are maintained this way, the bidirectionality, so you can always fetch from genre, from actor, or the other way around, right? And how do you fetch the data? You fetch it using the query embedding graph, where you give the entity the actor name and the relation name, or the movie name and the relation name, and this way you get all the information. And the other function is the query movie ID. For a given movie ID, you will fetch all the information. As told you, the node has all the information, and you need this ID because my RAG embeddings are encoded. So my embeddings are encoded for these IDs. So, and the tool which fetches the data from the IDs, those IDs needs to be checked here, and that's where this file is required. I mean, I won't go into fast details because it's very simple, very straightforward. For the agentic tools, these are all the tools I told you about. It's not a big deal, but let's see the results once. So you can see the graph got loaded. The graph created 4 million nodes, and 3.8 3.8 lakh nodes, and more than 35 lakh edges. And the fast the embeddings were 45,000. Only there are 45,000 movies. For all the movies, we have the embedding with the rack and retrieve. So let's see the first one. So which movie was released before 2003 where Quentin was involved, right? So it calls the tool. So for example, this is the tool agent which calls the tool. Acting in movies and call all the information where it acted in movies, and wrote movies, produced movies, directed movies, because you need to have all the elevations, right? And now it got every result from the tool, and with that it generated this information, right? That's how it does. And this is how tool agents do. But let's see how code agents would do. And code agents are different. You can see it set up everything, added in movie as a Python call where you define all the as you can see earlier it was doing individual calls that tool agents. Whereas the code agents defined all the relationships and created the set called Tarantino movies, and then collecting all the movie IDs here, which is very very smart, right? And this is how it connected all the movies. And once it got all the movie list, but then it had all the list of movies, and it connected all the movies data, and now it was able to retrieve way better result. So you can see here I've compared the two movies. For the tool agent, very simple, 6 movies. But for code agents, it's very able to identify a lot many information because it's well structured. You write the code and you get the results back, right? And this is why it produces way better results. Similarly, for other query like here, top 10 movies similar to Inception theme, you have tool agent and then you have code agents. I won't go into details of each one of them. You can see it took 16 seconds for each of them, but you can see how the results changes because the query method is different, and you can see the tool is way better because it finds the theme, which is the thievery, the dream stealing ability which was on the Inception, right? And that's what similar to Inception core theme. So you can see this one is producing way better results. So code agents generally give way better results than normal tool calling agents. Like how is Tarantino connected to Thomas connected to Christopher Nolan tool agents again. The results will be very similar because Tom Hanks, good director of movies in which Tom Hardy is appeared. Tom Hardy is connected in Inception and everything. So you can see it's very similar to being given here. Right. Connected. Tom Hardy worked with that different directors. The only issue is code agents tends to not get a well structured output. And that's the only issue with the code agents. But again, for example, which director worked with both Leonardo and Brad Pitt? So you can see here, for example, Quentin Tarantino worked with both of them. It worked with both, and Scott worked with both of them. But you can see Cohen brothers here. It says that direct both directed Brad Pitt movies, but there is no evidence. But still, it gives. So this is why it hallucinates, right? Whereas code agents, it never hallucinates. because it codes and then gives you the answer. The chances of hallucinations are slim to none, right? And there are different movies I can go on and on about it. So, for example, with code agents, it's so much better. So much all movies, Christopher Nolan worked with actors, also worked with Tim Burton. So you can see Tool is only able to find three of them, whereas code agents find so many more, right? And this list is based on that relationship in the movie knowledge graph we had. So it's using the movie knowledge graph. So yeah, that's all. I mean, the graph the code agents are really good, but it's still a developing field. But I feel it's the future. And anyways, I will be sharing the code and the information. Do let me know if you have any questions. Thank you.